Hi, I'm JpaRepository University, Computer Engineering Department, 4th grade. Today I'm going to try to explain what is Spring Framework, Spring Core, Spring Boot, how Spring Boot works, how Spring Core works, and how a modern Spring Boot project do things. But before we start, I assume you to know Java, object-oriented programming, and Java programming. And I will put this my documentations link below. Okay, Spring Core. Spring Framework is a modular open source framework for Java. It's the most popular framework, and in core, the core concept it consists of inversion of control. So before we talk about that, I need to explain what is a POJO. POJO is an ordinary Java object that does not implement or extend a class interface. And POJO class have IDs and getters and setters. Bean is a kind of a POJO, but has some restrictions. Beans must be serializable, and its fields must be private. As you probably know, we make our fields private because of encapsulation of object-oriented. If you do not know object-oriented concepts, I really suggest you to check it now. So fields should have getters and setters to reach them because they are private. There must be a no argument constructor. Fields are only accessed by constructors, by getters and setters, as we know. XML. So XML is an extensible markup language. Spring cores use XML, but in generally you use annotations in your code, but XML is used with POM XML, like in Maven or other some property settings. So what is an annotation? Annotation in dictionary, annotation is a note added by a way of comment or explanation. In programming, annotation is a form of metadata that provides data about a program. That's how we manage our Spring settings, let's say. Okay, what is AOP, aspect-oriented programming? So we will see in later we have layers of our applications, and some things like security is a cross-cutting concern, which means it exists on every layer and affect every layer, like transaction management, logging, and security. Dependency is an object. If an object needs another object or uses another object, works with another object, it means they are dependent. For example, like an address and a person, a car and a person, and if you create a person inside a car, for example, I am writing a simulation, and when a person enters the car, that I create a person, like in Java, new person inside a car object, which makes it tightly coupled, very dependent. There's a dependency between car and person. So inversion of control. In this scenario, the control is on a programmer's hand because we get inside that object and create by typing new. But inversion of control says let's framework controls it. And this is helpful because in this easy example it's alright, but in real projects there are many objects that are dependent to each other, and inversion control take care of this. So advantages of inversion of control: decouples the task implementation from its execution. Models are pluggable, can be easily replaced with equivalent. Easy out the model or testing. And there is 3 popular ways of doing inversion control: strategy design pattern, service locator pattern, and dependency injection. Dependency injection is the most common one. An inversion control pattern dependency injection is, and whereby one object supplies the dependency of another object. So it promotes loose coupling. As you can see, the traditional method, this is our private object, and in person we are creating a new address, as I just said. But in dependency injection, this is a constructor, by the way, and this is a constructor injection. We are getting the address and we are initializing that instance. There are 3 types of dependency injections: constructor-based, insider injection, and property-based injection. The most common one is constructor-based injection. There are 2 ways of doing constructor-based injection. One, we can either configure the beans in XML, or we enable application context XML. So this is a component scan. It scans our beans, POJOs, and checks for annotations. And in our Java code, we type by component, so the scanner can find it, and then autowire on the constructor, so it makes a constructor injection. Spring by default wires the beans by their type. If there are more than 1 beans of one type, qualifier annotation can be used. And setter injection, setter-based dependency injection, is achieved through a setter method. It's preferred in no argument constructor, etc. In XML you can do it like this, or by using the component scan we can do it like this. This is the most common way, by the way. XML is not used popularly, but we will see in a couple of minutes we actually do not use even these. Maybe these constructor injection by autowire, but in generally we do different things. We will see in a couple of minutes. And property-based injection, we can also use this one on top of the field. In considering the Spring documentation, we use constructor injection for mandatory dependencies. For example, the dependency they use while working, like person needs address, etc. Setter-based injection should be used for optional dependencies, like there are JSON. If the file works with JSON, we give that in setter, or the file might work with XML, for example. And avoid property-based injection because Spring uses a reflection for field injection dependencies and it is costlier. So, application context. Application context is an object that loads the configuration, then Spring will start managing beans. And there are 3 ways of configure application context: XML-based, Java-based, annotation-based. And this is we just said there is inversion control, right? And Spring does this inversion control and controls the dependencies by this application context. Yeah, Ioc Container has several implementation classes available. These might be class path XML, file system XML, or web application context. For example, we create app context, class path XML application context. Spring Ioc Container, the core of Spring framework. It creates objects, configures, assembles their dependencies, manages their entire life cycle. The container uses dependency injection to manage the components. As you can see, yeah, this is how it works. Our POJOs enter here, Spring container, and configuring method of enters here, and it produces a fully configured system ready to use. It is really easy. Now it's time for Springboard. Springboard is an open source micro framework that provides Java developers with a platform to get started with an auto-configurable production grade Spring application. So Springboard uses Spring Core, but it has some advantages. It's it's a framework actually. It comes ready for us. For example, a layer system that we can use, and also an server, etc. Let's see. Yes, it's on the core. Standalone production grade Spring based applications with minimum effort. Layered architecture. Yeah, hierarchical layered architecture. So these layers only communicate with one below and one upper layer. And presentation layer, the authentication is done here, JSON translation. There's actually a controller there. And business layer, we do our validations, we check. Let me give you an example next. A persistence layer, the storage logic database, actual database. So there's a database, persistence layers gets data from the database and sends it to the business layer. For example, the user's age, like it's a pub simulation, gets user's age and sends it to the business layer, and business layer we check if the user is over 18, and in the presentation layer we send it to the front end with REST API. It's like controller, and on the front end it gets our API and does whatever it has to do. For example, writes you are you are under 18, you can't enter this pub, for example. And yeah, it explains here again. Presentation layer handles the HTTP request, translates the JSON parameter to object, and authenticates the request. Business layer authorization, validation. Persistent layer stores logic, translate business objects from database to real. See this Springboard flow architecture. So model, these are entities, and by using Java's JPI Spring Data, we create databases, and service layer uses databases or entities too, and repository class extended CRUD services, dependency injection, service layer, controller, HTTP. I just explained it. Yeah, we will see that also. Maven is an open source build to develop by Apache. So Maven has a POM XML file. So in POM XML file, you might heard jar files, right? It's like downloading from internet, I mean from online repository, but we just add XML, its name, it's like branch name, and then the version, and it finds from internet, or when we delete it, it deletes also from our project. It manages these packages. And POM XML, the core business unit in Maven, XML file contain information about the project configuration details used by Maven to build the project. So DAO DTO, it's kind of early, but let me tell what it is. And DAO is a data access object, DTO data transfer object. Their just names are similar, they're actually really different. Data access object is in a persistence layer. It's on top of the database, close to the database, and encapsulates hides implementation details about how stored in data storage. It's like gets data for you, like JpaRepository. DTO is a value object that is used to transfer the data between classes and models. For example, when we are sending entity between layers, we don't want to send entities. Instead, we translate it into DTOs. We will see it in a minute. Spring versus Spring Boot. Spring is a Java framework used to build applications, but Spring Boot used to develop REST APIs. Spring's key feature is dependency injection, but Spring Boot's key feature is auto configuration. Spring is used for Java enterprise development easier, and Spring Boot provides rapid application development features. Spring framework the faster application development, and Spring helps loosely coupling. Spring Boot helps making standalone applications. Spring framework to test Spring objects in Spring Framework, we need to set service explicitly, but Spring Boot has an embedded server like Tomcat and Jelly, and Spring Framework does not support in-memory database, but Spring Boot provides in-memory database like H2. In Spring, you need to configure manually Spring Boot. There are default configurations to allow faster bootstrapping. Spring requires a number of dependencies to create web app. Spring Boot does this for you. As you can understand, Spring Boot has a lot of bootstraps, default things to make you focus only on the application. And Spring Boot auto configuration, speed up and simplify development. Initializer. So when we are creating an application, we use an initializer. Check it. So this is an initializer. We select the Maven Java version. We give names, jar 11, and we add dependencies, and we can download a file from this way. Yes, build to Maven Spring Boot version dependency language. It's a helpful like initializer. It makes you start faster. And application properties. So application properties is a file inside your Spring application. Here, you can define your settings. For example, I define database settings here, and applications title, version, server ports. These values has defaults, some of them, like this one and this one, but these you need to set them. Spring annotations. Core Spring annotations. Add component configures the bean class. It's on top of the class. At component, the configuration class supply bean added to an Ioc container. Component scan. For example, we have component here, auto-wired, qualified, and configuration. Component scan is on top of the configuration class, but these are not used in professional projects. Lazy value, I'm continuing. Property resources, auto-fired, qualified. These are core things. Let's see Spring Boot annotations. At Spring Boot application indicates the main method of the Spring Boot project, marks a configuration class, and that declares one or more bean methods and also triggers auto configuration and component scan. It combines three annotations: configuration, enable auto configuration, component scan. Property resources. Am I skipping something important? Oh, here. Note, auto-fired is not used anymore. Instead, use Lombok all args constructor on a private final field. And we will see in a minute. Note, as a Spring 4.3, auto-fired become optional on classes with a single constructor. Using auto-fired it makes harder to test it, and it's not used commonly anymore because of that. Oh, I skipped this one, sorry about that. Stereotype annotations, these are important, these are used. The Spring Framework provides three other specific annotations to be used when marking a class as a component. These specific component annotations are service, repository, controller. I explained it before. We said there are layers: service layer, repository, controller layer. We are indexing these layers with these annotations. At service indicates these beans are used in service layer and holds business logic utility classes. At repository indicates these beans are used in DAO or repository and deals with CRUD operations like create, read, update, delete. And controller indicates these beans are front controllers used in REST web services and responsible to handle user requests. And Enable auto configuration enables Springboard auto configure the application context, so Springboard automatically creates and registers beans. It was constantly used with configuration and component scan. It is used when we want to exclude, for example, here. For example, we want to exclude data source auto configuration.class. MVC and REST annotations. These are also important. Request mapping. This is used in controller layer. A request mapping, a method that and the class level annotation that is used to mapping between the request path and handler method. The value attribute of request mapping annotation on a class is used to specify the URL pattern. The method property of request mapping annotation on method is used to specify the HTTP method. For example, in our controller, we define it by using controller annotation, and we are given the base path. For example, in writing localhost 8080/welcome, and we get this when, of course, the project must be project has to be run. And request mapping, this is also will change, but let's see. Request mapping, we are defining its method by get. But as you can see here, we have a better option by just saying at get mapping. This exactly means this or this. It's easier to read, so we prefer that. What we have, let's see. At get mapping, at post mapping for post operations, put mapping, patch mapping, delete mapping. And we also have exception handler, init binder, and path variable. Path variable used to retrieve data from the URL. Unlike request param, this annotation, do we have request param? No, we will see in a minute. Okay, and this annotation enables the controller to handle a request for parameterized URLs. For example, we have localhost 8080/books/ this is ID. And we want to retrieve ISBN number, sorry, not ID, ISBN number, this, from the URL as a method argument. So we do this, request mapping, oh, no, not that one, we prefer this one. At get mapping /books/ISBN. And here we give path variable for the ID, ISBN. So by entering this, we can get the ISBN for our string ID. Request attribute, used to bind the request attribute to a handler method parameter. Request body, used to convert inbound HTTP data into Java objects passed into controller's handler method. Request mapping is post consumer application /JSON. Response body, request header, used to map controller parameter to request header value. Request param. Request param is important. For example, we say get mapping, say hello, and we get following this. When we enter this one, it gets these. Say hello. It's not, by the way, be careful, this is request param, not path variable. Request param, name by Bahadur, surname bar Memis. Request part can be used instead of request param to get the content of specific multipart and bind method to argument annotation. Response body, used to transfer Java object returned from the controller to a resource representation requested by REST client. Response status, used on methods and exception classes. Response, is this a duplication? Sorry about that. Controller advice. REST controller. REST controller is important. It's used in our REST controller. We give the base, and then it returns this. Blah blah. Cookie value. Oh, cookie value. It's really similar to request param. cross-origin. Okay, Lombok. Lombok is a Java library tool that is used to minimize, remove the boilerplate code, like getters, setters, constructors, handled by Lombok, increasing the readability of the source code and saving space with using some annotations. Lombok works by plugging into our build-up process and auto-generating Java bytecode. For example, by just adding these annotations on top of our class, we implement getters, setters, no argument constructors. We can also add all args constructor and required args constructor. This is very important because we just said we are not using it auto-wired. Instead, we are using required args constructor. Generates a constructor with required parameters, final fields. So we are implementing constructor injection by using required args constructor. It does not generate any argument for non-final, initialize final, static initialize non-final fields. ToString generates a ToString method, includes in all class attributes, and equals hashcode, creates hashcode. Data sets getter, setter, required args constructor, ToString equals hashcode. For example, this is an entity. Add data, setter. Oh, we are excluding. Yes, we are excluding setter. No, we're just giving setter for ID and getter for this one. No, we are exclusion. Sorry about that. Yeah, there. We are excluding them. Value. Not important. Field defaults. Builder. Builder is a design pattern. We can just add builder and it creates our builder design pattern. As you can see. Hibernate. Hibernate is an ORM. It's an object relational model, and we create our POJOs classes, Java classes, and we add Hibernate annotations on them, and it creates our database tables by our objects. Add entity, we define entities by add entity. Add table, we define its names. These are important and used. ID indicates the ID of our table. A generated value, for example, IDs increase, and this does this. But when we do this, it doesn't work well. It works well, but it uses more memory. Instead, we prefer using sequence generators. And sequence generators, database objects that generate incremental integers on each successive request. Sequences are more flexible than identifier columns because sequences are table-free that may pre-allocate values to improve performance, and same sequence can be assigned to multiple columns and tables. And table generator defines a primary key generator that may be referenced by name when a generator element is specified for generated value annotation. Name is the generator's name. It has to be unique, so we use our class's name. If we use, for example, accidentally another class's name, it may use the same generator and they might increase it together. Column, we define our columns in a table, and the important parts are, if we are using a foreign key, we give name and give ID as a prefix. This is not a must, but this is a good practice. And for big decimal values, we can give precision and scale. We also give names. And for enums, we add enumerated enum type string. if it's a string, of course. So if someone changes your enum order, your application still works. And there is also updatable and insertable. If updatable is false, the field will not be written in the query when committing to the database. If insertable is false, the field will not be written in the insert query when committing in the database. Version. So used for optimistic locking while performing update operations. When two tables work together in an update, it uses locking. Temporal indicates in which format the date will be written to the database. So it's used for dates, and we have 3 formats: date, day, month, year, time, and date time. And timestamp is date time. Transient is used for booleans. It is used in case where we want a field to be in the POJO but not in the database. Oh, sorry. Yeah, it's used for booleans. I mean, if you want your boolean to be in the database, it's not used, but in this case, yeah. A LOB stands for large objects. We use with byte large objects or char large objects like clob or blob. Blob like byte array here, and clob is like char array, but they are both the LOB large object. And also, if the text is large, for example, you can use it on comment if you are holding a comment in your comment table. So there are relations, as you might know. One-to-one is used, one-to-one relation, like DNA human. One human has one DNA, and is used like this. And this is the other part, like human part and DNA part. Cascade var, there's cascade. No. There's fetch, orphan removal. Cascade is like they behave together. If one is deleted, the other is deleted. If one updated, the other deleted. Fetch and orphan removal. Many-to-many. There's many-to-many relationship. As an example, a book can have many writers, and a writer can have multiple books. And it's used like this. You need to hold it in a collection. This is a way of doing, but there are other ways of implementing relationships between tables. For example, holding the ID, like a foreign key. And there's many-to-one, one-to-many. With mapped by, it's possible to add to the entity without creating a column in a bidirectional relationship. It can be used when joining the cities list with the country object. Mapped by. And join column is used when an entity is defined in the entity. It helps us to specify the properties of the relation column to be created. There's foreign key. This is deprecated. Index deprecated. H2 database is a lightweight relational database which is embedded in the Java application. So you edit in POM.xml to add the jar file, and later you can do CRUD operations. When you run, H2 runs, and when you close, the all data will be deleted. HTTP methods and messages. So HTTP is a hypertext transfer protocol used for fetching resources such as HTML documents. HTTP methods are get, head, post. Get is for requesting a resource. Head is for requesting only the headers. Post changes content in the server. Put request server to create a resource. Delete request server to delete a resource. Connect. Request to start two-way communications. Options request permitted communication option for a given URL or server. Trace used for debugging, in which echoes back inputs. This is for checking. And there are error messages coming from responses. If it starts with 1, it's an information message. If it starts with 2, it's a success message. If it's 3, redirecting messages. If it's 4, it's a request error message. It means your requests are wrong, client's requests are wrong. And if it starts with 5, it's a server error message. Swagger is a set of open source tools that can help you design, build, document, and consume REST APIs. REST API is an application programming interface. The design principles of REST, representation, transfer, architectural style. An API is a set of rules that define how an application or device can connect to and communicate with each other. REST, representation, state transfer, Roy Fielding's derivation of the web's architectural style. In a RESTful web service, requests to a resource URI are answered with data in the form of HTML, XML, JSON, or some other format. URI is Uniform Resource Identifier and a syntax that assigns each web document a unique address. An endpoint is a method, the name given to your method created for a specific purpose on the API. So web service are backend and client. For example, this is our service on Google, let's say, and client is my laptop. I request to see google.com. It goes to a web API, and once below, like for example, service layer, repository layer, database, and goes back and to controller and web API and sends response, and we get response on our HTML, etc. So I skip these parts. Design and REST APIs. So this is not a must, but this is a good practice. Decide the 3-letter abbreviations of the tables and attributes inside them, and also a gen for a general class. Packages are created with the same name, and inside each of these 3-letter abbreviation name packages create DAO or repository, DTO, entity or model, service, and entity service and service, and other services also can be here, controller, converter, and enum packages. The URL is a sentence where resources, controllers, and classes are nouns and HTTP methods are verbs. You will not have a problem with URLs that are shorter than 2,000 characters, but on over 2,000 characters that may cause error. In controller, there can be only one HTTP method type, get, put, delete, etc. method in a path. So if you want to use multiple gets, you need to change the path. A good practice example, API version 1, if we share our APIs, we want different versions, so if we change our controller, it will not cause error on theirs. And there's tests. For example, it's a plural, be careful about that, and then say hello. And if we enter, this is localhost, it will be run on our localhost. 8080 API version 1 test say hello, we can get hello. There's Java reflection. I skipped that. It's not about our concept. JPI, it's a collection of classes, like we said, repository layer, right? This JPI creates a JpaRepository, for example, predefined methods to reach database, like for CRUD operations. So MapStruct, let's see what we have. Okay, let's explain from here, and then we can keep going. How long? 22.